Welcome, eighth graders. Today we're going to be taking some notes on mechanical energy and the conservation of energy. This is under the middle school standard, physical science 3-5. So this is going to be page 2 of your notes. I would like you to set up your note page like this. And then we're going to answer this essential question in this lesson. How are different types of energy used? So I'm going to write an essential question here. How are different types of energy used? We've talked about a couple different types of energy at this point. We've talked about kinetic energy, motion energy, and we've also talked about potential energy. And we learned about 3 types of potential energy. Potential energy could be gravitational due to height. It could be elastic due to stretching or compressing of objects. And it could also be chemical when you store it in chemical bonds like gasoline or food. So we're going to be following along in the book today on page 146. At the top of page 146, it asks, what types of energy does an object have as it is both moving and off the ground? It is both moving and it is off the ground. What type of energy would it have? So this is what's called mechanical energy. Mechanical energy. When the pendulum was swinging in the lab, so the pendulum that we looked at yesterday, did it have kinetic energy? Well, if it was moving, we saw it would. It has mass and speed, so it had kinetic energy. The pendulum was also above its resting height, so it had gravitational potential energy. The pendulum had both kinetic and potential energy. Sometimes examining the individual energy types is needed. However, it is important to consider the energy of the entire system. The sum of all the potential energy and the kinetic energy in the system is mechanical energy. All forms of energy are measured in joules. So what this is saying is we have kinetic and potential energy in our pendulum that we looked at yesterday. The pendulum we looked at was a swing set, or the wrecking ball in the video. And because it is both moving and has mass, it must have kinetic energy. Because it is above the ground and it has height, it also has gravitational potential energy. So it has both of these types of energy. And if you were to add all of the energy together and get the total energy, all the kinetic and all the potential, this is what we're going to call mechanical energy. So we're going to go to our notes and we're going to take a note now on what mechanical energy is. Mechanical energy is the sum. To sum something means to add it up. The sum of all the kinetic and potential energy. Make another note here. It's measured in joules. So we can measure things like distance in meters and kilometers. We can measure mass in terms of grams or kilograms. And we can measure energy with this unit that's called a joule, and J for joule. So now we're going to write a question on the left-hand side. And I'm going to say, what is the total energy? Mechanical energy is really the total energy. So my question I'm going to write is, what is the total energy? Okay. We're going to go back to the book now and continue learning about kind of how again, how does it get used? How does this kinetic and potential energy, this mechanical energy, how is it used? Okay, so now we're looking at page 149 in the workbook. And we're going to really focus on this image here with the basketball. So I'm going to read the paragraph on the left-hand side. Changes between kinetic and potential energy. During the change of motion of many objects, kinetic energy changes to potential energy, and vice versa. Think about tossing a basketball in the air. The basketball is moving fastest and has the most kinetic energy as it leaves your hand. So I'm going to highlight this in pink here. Has the most kinetic energy as it leaves your hand. And that's what we see right here. When you push the ball up, you're giving it all of this motion, this speed. It's at the bottom point of you throwing it up. So it has no potential energy. It's all kinetic. As the ball moves upwards, speed and kinetic energy decrease. It's left your hand. It's not speeding up as it goes up. It's actually slowing down. It's losing its kinetic energy. However, the potential energy is increasing because the ball's height is increasing. We see this right here. The potential energy got greater while the kinetic energy went down. Kinetic energy is changing into potential energy. At the ball's highest point, the gravitational potential energy is at its greatest, and the ball's kinetic energy is at its lowest. So I'm going to highlight this here. At the highest point, you have no more speed in the ball. It kind of comes to a stop. But this is the highest point. So all of that kinetic energy has now become potential energy. As the ball moves downward, potential energy decreases. At the same time, the ball's speed increases. We see this right here. As the ball's going down, the kinetic energy starts to come back. We're losing height, but we're gaining speed. Therefore, the ball's kinetic energy increases. We have potential energy transferring into kinetic energy. Immediately before the ball reaches the other player's hand, the kinetic energy is back to its maximum value. So I want to go to our notes and we're going to try to draw something like this, because this is an important way to kind of visualize it. So what I want to do here is we're going to draw something. We're just going to draw an object. And I'm going to draw an arrow that it's going up. It's still going up. Highest point. Coming back down. Coming back down. Okay. And we'll make a note here that at the top, we have maximum potential energy. This is where we have the maximum potential energy. And on the bottoms here, this is where we have maximum kinetic energy. Now, as the ball is going up, as it's going up, as it moves up, you are gaining potential energy and you are decreasing kinetic energy. And now as the ball is at its top point, you have all this height, all this maximum potential energy. It's going to go back down and it's speeding up as it falls. So you are in this Ipshin image, you are decreasing potential energy, but you are increasing kinetic energy. Kinetic energy is transferred into potential energy. As the object travels up. You're losing your kinetic energy, or you're transferring it into potential as you travel up. On the way back down, it's the opposite. Potential energy is transferred into kinetic energy as the object travels down. Okay, and so this note right here, I'm just going to make a question for it. How does kinetic and potential energy change? And when you take your notes, if you want to give a little bit of extra room between your two notes, you can do that. And I'm going to go to my book one more time. Go back to the book one more time. Let's read this paragraph on the right side. Did you notice that as the kinetic energy of the basketball decreased, the potential energy increased by the same amount? The amount of kinetic energy at the beginning of the toss determined how high the basketball would go. If you give it more energy at the beginning, your ball is going to go higher. On the way back down, the height the basketball reached determined the speed of the ball. The higher the ball is, the more speed you're going to have as it comes back down. And this determined the amount of kinetic energy the ball had as it fell. Think back to the pendulum that we watched in the video yesterday. You may have noticed that the pendulum reached the same height on the other side as the height you released it from. We saw this in the video when it came to his face. This is because the potential energy transferred to kinetic energy as it swung to the bottom of the arc. Then the kinetic energy transferred to the potential energy as it swung back up to the other side. You have energy constantly transferring back and forth. Now, later in this lesson, we'll explore how a pendulum can gain more total energy and what happens to total energy over time. So let's look at this image here to kind of see that. Right here, this is a golfer and he's hitting a ball. The moment he strikes the ball, as the ball separates from the club, kinetic energy is greatest. It's at its maximum point. and the potential energy is the lowest. Our total energy is this full bar right here. Notice it's completely filled. Now, what happens as the ball travels upward? As it travels upward to this point, you've lost some of your kinetic energy, you've lost some of your speed, but you've gained height, so you have more potential energy. Notice the total energy is still the same. The total energy remains the same. Again, the ball's at the highest point. The kinetic energy is minimum. Potential energy is maximum. But the total energy, the mechanical energy, is still unchanged. And as the ball falls to its last point here, where it's all kinetic again, it's lost its height, all of my total energy is the same. The pattern continues as the ball moves downward. The decrease in gravitational potential energy and increase in kinetic energy does not change the overall amount of energy. The total energy does not change. And that's an important point to kind of recognize here. So we have one last note to write down. That's what's happening. The energy, the total energy does not change. So this is what's called the law of conservation of energy. It states that even though energy is always transferring, energy is not created, energy is not destroyed. We are not creating any energy here. We are not destroying any energy. The total energy is always the same. So let's put this down as our last note. I'm going to add to my note here. I'm just going to star. Total energy remains the same. Okay. So, energy can be transferred but energy cannot be created or destroyed. And my question I'll write on the left-hand side is, what is the law of conservation of energy? So put those down in your notes for page 2 of your notes. I'll expect to see this next week. And you should have a summary done. We'll do the summary in class sometime next week.